Hello geometry students, today's learning target is to write proofs related to triangles. And the steps for success are first to write the statements, then you mark the diagram, and you write the reason. And we're going to go through a couple examples. For the first example, I actually gave you the statement. So if you look at problem number 1, we are told that BC is congruent to DC. And I'm highlighting that in blue. The reason is it is given. So if you look at this problem, I'm going to underline the word given. And I'm going to mark that BC is the same as DC. So I'm going to do some color coding. The second given is angle BCA is congruent to DCA. And I wrote that down in step 2. The reason it is given. And if you look at the problem, I'm going to underline the word given. So the first two statements are given. And I'm going to mark that angle BCA. So BCA is this red angle. And DCA is this other red angle. And then we talked about in the last unit that AC is congruent to AC, meaning I could put this mark down the middle. And that is called the reflexive property. Now we wanted to prove triangle ABC is congruent to triangle ADC, which is the last sentence. And if you look at the diagram, the reason is side, angle, side. So the idea here is you always start with the given, you mark what you know, you might use the reflexive property, or we did use the reflexive property, and then you say why the triangles are congruent. Let's take a look at problem number 2. So we are given D is congruent to angle B. So the first reason is given. And then I'm going to mark that angle D is the same as angle B. The second given is here in blue, that AC bisects angle BAD. So that is given. So what does it mean that AC bisects angle BAD that I'm highlighting in yellow? It means these two angles that I'm marking in blue are congruent. And I'm going to fix that double line there. So an angle bisector means the angles are congruent. And if you look at the next step, step 3, I wrote that angle BAC is congruent to angle CAD, and the reason is definition of angle bisector. Then, like the last problem, we can mark the line down the middle that AC is congruent to AC. That's step 4. That is called the reflexive property. And the goal was to prove triangle ABC was congruent to ADC, which is step 5. And if you look at the diagram, the reason is angle, angle, side. So if you look at problem number 2, the main idea was angle bisector cuts the angles in half. Now let's take a look at problem number 3. The first thing I'm told is X is the midpoint of QS. And the reason is given. I'll put a little star next to that. The second given, I'll put 2 stars, is angle Q is congruent to angle S. So I'll put these red marks. And let's go back to what it means to be a midpoint. If X is the midpoint of that blue highlighted segment, QS, that means I get to put 1 tick mark on QX and 1 tick mark on XS, which is what I wrote right there. The reason I get to do that is the definition of midpoint. And then if you look at this diagram, we have a pair of vertical angles. I'm going to mark them in the middle. That's what I wrote in step 4, that angle QXP is congruent to SXR. We know that vertical angles are congruent. So that's the reason for step 4. And then the triangles are congruent. That's what we wanted to prove. I'm highlighting that in yellow. It's in step 5. The reason they are congruent is angle, side, angle. Let's take a look at one more example where I filled in the proof, at least the statements. So EA is congruent to EC, that is given. And I'm going to mark EA and EC are congruent. The second given is B is congruent, D is congruent to B, that is given. So I'm going to mark angle B and D are the same. And you always get the mark vertical angles. That's what I have in step 3, that DEA is congruent to BEC, the angles. And the reason is vertical angles are congruent. We wanted to prove triangle ADE was congruent to triangle CBE. If you look at these diagrams, that is angle, angle, side. The next example we did in class was related to an isosceles triangle. So we're told that triangle GKL is an isosceles triangle. I wrote that in step 1. That is given. The second given was M is the midpoint. So that is given. And now I'm going to come back to what does it mean to be an isosceles triangle? Well, if that triangle is isosceles, that means the legs, GK and KL, are congruent. That's what I wrote in step 3. And the reason is that is definition of an isosceles triangle. We were also told that M was the midpoint of GL, so I could put these 2 blue tick marks, which I wrote in step 4. That is the definition of midpoint. So you could put those blue marks. And like we discussed earlier, you get the line down the middle, KM is congruent to KM. That was called the reflexive property. And now if you look at the 2 triangles, we wanted to prove that they were congruent, and I'm highlighting in yellow, which is in step 6. The reason is side, side, side. So in problems 1 to 5, I gave you the statements. Now in problem number 6, this is what the test will look like, where you're going to have to fill in the statements and the reason. And we always start with the givens. So the first thing we discussed in class was AB is congruent to CB, that is given. And I'm going to mark those in the red tick marks. Second given is BD bisects angle ABC, that is given. Now what does it mean that this BD bisects angle ABC? It means the angles that I'm marking in blue are congruent. What I mean by that is angle ABD is congruent to angle DBC, and that is the definition of an angle bisector. Then, if we look at these triangles, we have a common side, meaning BD is congruent to itself, BD. That was called the reflexive property. And now if you look at the triangles, they are congruent, and then we wanted to prove it, and I'm highlighting this in yellow there. So that's going to be my last sentence. Triangle ABD is congruent to triangle CBD, and the reason is side, angle, side. We didn't use the Desmos here, so I'm going to cross off problem number 7 for this given school year.